Often when marketing or presenting a project, it is necessary to show how it is assembled. A photorealistic animation can help to effectively communicate the process to your target audience and help them envision your idea coming to life. In the following video, I will show you a simple, extensible way to create these animations to serve as a launching point for you to create beautiful animations like the ones you see here. The process I will show you today can be extended to arbitrarily complex assemblies and with minimal research can get you extraordinary results. To follow along with this video, you will need SolidWorks. You can also use your favorite CAD software or an existing model, and Blender to create the animation. The idea is to leverage the superior capacities of each software in their suited domains. Because this tutorial is meant to be extensible, I'm going to create a simple model to demonstrate the two main steps used in any assembly, namely translations and rotations. I recommend trying to follow along with your own geometry, but keep it fairly simple for this first run. First, open a general Blender file. Press the letter A to select all, then delete everything from the workspace. That way we can start with a nice, clean, empty workspace. Now we will import the STL files we created earlier. Because we saved them from the assembly, they will be in the correct relative positions when we import them. I find that switching from the timeline to the dope sheet makes adding and modifying keyframes much easier. I am just going to add a keyframe for every part at this location. This is the final location I want everything to be in at the end of the animation. To insert a keyframe, just select the part and press the letter I on your keyboard. This will make the menu pop up where you select the parameters you want the keyframe for. Because I am just translating and rotating parts, I am just keyframing the location and rotation. You may want to animate parts changing size, in which case you would keyframe the scale too. Now I just slide to a new frame on the dope sheet, move the part, and add another keyframe. If you want to check your animation, just play the video and visually inspect that it is doing what you want. When you're a rotating part, it is important to set the origin to geometry. This way the part rotates about its center. Sometimes this reverse engineering method leads to weird behavior, so just redo the final keyframe to fix it. Then I'm going to add a camera by pressing Shift and A, then selecting the camera from the menu. Then press 0 to change to the camera view, and make the camera follow the view. This allows you to change where the camera is pointing by using the controls you use to change your view. Now with the camera selected, we can add keyframes in the same way as for the assembly. Just move it to the location you want it at a specific frame and add in the keyframe as before. Now I'm just going to add a plane as the floor, and scale it up by pressing S and then dragging it out. Here I just selected the part and switched to the edit mode by pressing tab, and I'm just going to right click and set it to smooth shading. You don't need to do this. Then press tab again to go back. I'm also going to set this part to smooth shading. Once again, this is totally optional. I am going to switch now to the render view. And add a light much in the same way we added the camera. Like everything else, you can move that light around and add keyframes. Now I'm just going to save the project. And change some of my render settings. In an effort to keep this video to a manageable length, I'm not going to cover these settings. Blender has so much functionality that I just cannot hope to cover it. So in the description, I will link to some videos that cover these topics. The final quality of your animation depends highly on your rendering settings and materials, so I would really do some research in this area. Looking on forums, you can find info on specific materials and a bunch of other things related to Blender. Here I'm just going to quickly add an aluminum-like material, but once again, I really recommend more in-depth research on materials if you want a photorealistic animation. You can render an individual frame by pressing F12 to quickly check your settings, as well as seeing the rendering time, which is useful to calculate the overall rendering time for your animation. Realize that I have sped up these renders in post-processing. I wish my computer was this fast. One final note is that I like to save my animations as a sequence of images. For some reason, this seems much more stable and Blender doesn't crash as often when I use this approach. And that is it, just render the animation. Here's a quick way to create an animation from the images we just rendered using the free video editing software HitFilm Express. It is as simple as loading in the images as an image sequence, dragging that into the video track, then exporting the video. And that is all, we quickly have an animation. And that is it for this video. If you found it useful, don't forget to like and subscribe, and support me on Patreon. The process outlined in this video can be extended to arbitrarily complex geometries, and I would love to see what you all come up with. The next video will be on a similar topic of animating mechanical systems in Blender. Once again, thanks for the support and have a good day.